Hello and welcome to another video. In this video, we're going to be working on minimum window substring. And this is a really common interview problem, and this is also a pattern that happens a lot, so it's going to be a good one to learn. So in this problem, you're given two strings s and t of lengths m and n, and you want to return the minimum window substring such that every character in t is present in s. And if there's no substring, return the empty string. So for this first example for ABC, this shortest substring is this bank right here. And in the second example, it's the whole string in A. And in the third example, it's not possible. And so they tell you like the constraints and stuff. So m and n, the length of each string, is up to 10 to the fifth. So you're looking for like an n or n log n solution. So we are going to look at this m plus n time. That's what we're going to be doing. So essentially for a string, let's actually just write down this example here, this Adobe something something. So let's just write this down in an array. Let's actually use an indexed array, ideally. And maybe we'll add a few more indices. So let's just add these characters in. So A, D, O, B, E, C, O, D, E, and we need 3 more, looks like. So let's take 3 more, put them over here, and update these. So 10, 11, oops, and 12. And this is going to be A, N, C. So the pattern for this problem to do this, to figure out like what's the smallest string, like first of all, how do we know if a string is in a string? That's the first part, like not even considering the smallest. To know that a string is in a string efficiently while traversing, it's pretty simple. What you do is, first of all, for the string you're looking for, like this is going to be the substring, what you want to do is you want to actually make a dictionary of the string. And basically, so you'll make a dictionary of letter counts. So in this example, we have A with a count of 1, B with a count of 1, C with a count of 1. And now as we traverse through like our main word, we know how many letters we have to match. So we have to figure out like, okay, for our string T, how many letters are in it, which we can know from the dictionary, and that's how many letters we have to match. So we have to get 3 matches. So we're going to keep track of how many matches we have, and if our matches equals the number of letters in T, then we're going to say this is matching. And how we're going to tell what's a match, we're going to do the same thing for S. We're going to maintain a character count. And so anytime a character is in S and is in T, and there's a match, then we will say there's a match. So that's what we're going to do. So I'll kind of walk through this and make it, it's going to be a little bit easier as we go through the explanation. But essentially, so this is going to be our T count, and we're going to go through the letters in S. So we're going to have a sliding window, and we're basically going to keep making our window longer and longer and longer and longer until all of the characters in here are in our word. So we'll just like keep extending it, extending it. Let's say this is, or actually, so the first window that will have all the characters will be this. Then, once we know this has our characters, then we're going to see how far we can shrink it while still having all the characters. And we will shrink it until it's no longer valid, and then we'll keep going from the right side. And I'll kind of show why like all these things need to happen. So let's have 2 pointers for our sliding window. So we'll have this left and this right pointer. So let's walk through what's going to happen here. So remember, we need 3 matches. We have 0. So yeah, so we have 0. So first thing, we're going to go through this letter A. We're going to update its count in our dictionary of S. Then we're going to check, is this a match, right? Like, is the letter count of this letter equal to the letter count in T? And in this case, it is. So that means we have a match. So we have a match, so we're going to say we have 1 match. Then we are gonna, we don't have all our matches yet, right? Because we need 3. So then we're gonna go to the next one. Let's actually maybe, how do I fit this all? Maybe let's do it like this, and then I'll just move it. Actually, I think I can move this. Yeah. Let's move it like over here would be good. There we go. Okay, perfect. So yeah, so we have a match here, and now here we check this D. So you can just ignore letters that aren't in T, like that'd be fine too. But in my case, I will just leave it. So I'll say, let's increment D, is this a match for this T? No, it's not. So we'll keep going. We don't have the matches. So let's go over here. Let's increment O. And it doesn't really matter since you have too many characters, like because you can only have 26 characters total. It doesn't really matter. Like if you're using too many characters, it'll still be super fast. Then for the B, we'll increment B. So let's do that. So let's put B over here. And let's just write down how many matches we have and how many matches we need over here. So we need 3, we have 1. So B is a match, right? B is a match. We have 1, we need 1. So now we have 2. We still don't quite have 3, so we need to keep going. So we're going to go over here. We're going to add the letter E with a count of 1. That's not a match, so we keep going. Then we have C with a count of 1. That is a match. So now we do have 3 matches. And now the most efficient way to do this, so you could get the substring every time. Like you could just be like, okay, so I know this substring is fine. Let me just get it. But then the problem is, let's say your string is really long, like 1,000,000 characters. And you're going to keep shrinking it like over and over and over and over and over. You don't want to just like get this substring and then shrink it by 1 and then get this substring and then shrink it by 1 and so on. So instead of getting the substring, we're actually just going to maintain the index of the start and end of the string and the length of the string. So we started out with like a length of like infinity or something, but now that this is valid, we're going to maintain our result. So our result here is going to be a string of length 6. And it's going to be from 0 to 5. We can just maintain those in variables. Then what's going to happen is we're going to try to shrink our window until we no longer have a match. Because like if this is valid, then adding a character is never going to be better, right? Like we're never going to like extend it in some way because this is like small, right? So we want to keep shrinking it until it's no longer valid. Because then like we basically need a window shorter than this, right? And let's say if we shrink it here, if this was valid, then once again, we're never going to want to like extend this because this is going to be the best answer. So that's why you want to shrink it until it's no longer valid. So let's shrink it from the left. So we're going to shrink it over here. So this A goes away. And was A a match before? Yes, it was. So now we needed 3 and now we only have 2. Right? We only have 2 matches here. So now we have an invalid window again, and now we need to basically keep going to like the next character. So we're going to go over here and we're going to increment O. Is that a match? No, it's not. Like I said, you can write in your code where if the character isn't in here, just don't even bother putting it in here. That's totally fine as well. Then we are going to go over here. We're going to increment D. Is D a match? No, it's not. So we'll keep going. Come over here. Increment E. Is E a match? Yes. No, it's not. Sorry. So we'll increment it, but it's not in the other thing. Come over here. Increment B. Is B a match? No, it's not. So this is the other thing you need to do. So notice that here it was a match and now it's not. So if it was a match and now it's not, you need to make it not a match. That's the other thing, right? Like it used to be a match, but now we have too many. So now we only have 1 match. Yeah. So we only have 1 match. So we need 3. So we're going to keep going. Actually, I take that back. So actually, I do take that back. So if you have too many, it's still a match because you still have like the amount you need, right? Like if we need 1B, but we have 2, we still have that word in here. So I take that back. So this should still be a match. Yeah. The case it wouldn't be a match is when you're decrementing and they're equal to begin with, but then you subtract 1 from here. So you just need to have all of these in here. So even though you have 2 B's, that is still a match. Okay. And we still need 1 more, so we're going to keep going. Now we increment A, so we put in an A. Is A a match? Yes, it is. So now we have 3 matches again. 3 matches again. Now we need to check. This is a valid window, right? This is totally valid. We have ABC in here. Now we need to check, like, is this result better than our old one? Obviously not, because our old result was 6 length. But now we can shrink it up until it's valid. So we're going to keep shrinking it until it's no longer valid. And I'll explain it once again why we need to do that. So we need to get rid of this D. I'll explain it right after we make it no longer valid. Then we move this over here. We get rid of this O. Then we get rid of the B. Still valid. And I will note that as we're shrinking it, every shrink, we're going to check, like, now is it better than our result? Is it better? So far, it's still way too big, so it's not better than a result. So we're going to keep shrinking because it's still valid. Now we're going to get rid of an E. So get rid of an E. Okay. Now we get rid of a C. So first of all, before we get rid of the C, is this better than our result? No, it's not the same. So we can just keep the old one. Like either one of these is the same. So we don't need to make it shorter. So we're going to get rid of the C. And now once we got rid of the C, now we lost one of our matches, right? We had C for C. Now we don't. So we have 2, we need 3. So we're going to go over here. Now this is no longer a valid string. So then we keep going to the right. So we're going to add an N. Is it a match? No, it's not. And finally, we're going to add a C. Get rid of that. Add a C. Is it C a match? Yes, it is, right? That's what we were missing. So now we have 3 matches. So now that we have 3 matches, we check, is this string better than our old one? No, it's not. So let's try to shrink it. So we get rid of an O. So let's get rid of an O. O was gone. Did that get rid of a match? No, it didn't. So we basically just keep shrinking until we got rid of one of our matches. So D doesn't get rid of a match. There are no Ds. E doesn't get rid of a match. And now finally we come to this word. So by the way, actually when we came to this word is already better than our result here. So we would store this. So we'd say our result now is length 5 and our indices are 8 and 12. So we would store it here. And then we would get rid of the E, and now we'd come over here and we'd say, okay, this is still valid. This is better than our result. So it's going to be length 4, and our indices are 9 and 12. And it's easier to just do this every time as you're decrementing. You can only do it once, like to optimize it a little bit, but it's still going to be the same runtime. So I just prefer to just do it every time. Yeah, so this is valid, right? This is valid. Now we'd get rid of the B. So when we get rid of the B, now it's no longer valid because we only have 2 matches. So this is not a valid string anymore, and then we're out of bounds, so we're done. So the longest string, we look at what indices we had was 9 through 12, which is going to be here. And that's the most efficient way to get back to a string. You just maintain a length and a left and right index instead of doing substring every time. That's going to be the main thing that's going to make it slow, is if you get the substring manually every time you have a better index. Because imagine you're shrinking down from like 1 million, you have to get that string, then you're getting rid of 1 letter, get that string, and so on. Now you can probably, no, it just wouldn't be efficient at all. Like just getting a substring, even if you use an array, it just wouldn't be efficient. Like indices are the best by far, I think. Okay, so now we can code it. I think there were no other, yeah, this example is kind of easy. Now you can have a few quick little things. So you can say like if length of T is greater than length of S, return the empty string if you want. Like that would make it a little bit faster. If T is like 1 million characters and S is something small, this would speed it up. So that's one. Yeah. Okay, anyway. You could also do another thing where you can get like the count of every letter in T and the count of every letter in S. And if S just didn't have all of the characters in T, you could also return the empty string. But all those things are like not really going to help that much. So now let's go through the rest of it. So first we're going to get the count of every single letter in T. So we're going to say T counts equals, and in Python it's super easy. In other languages more annoying. You can use a counter, and a counter will basically just give you a dictionary with every letter in T and all of its counts. And you can write this yourself in another language in O of T. Okay. Now we have T characters, which is just going to be the length of T count. So this is how many matches we need, right? Like if T is ABC, then this is going to give us 3, so we need 3 matches. So we're going to keep track of a variable called matches, and the variable needs to equal T characters. Then we're going to initialize our result to just be like infinity, and then we're going to check at the end, like if the result's still infinity, that means we didn't find anything. And we're going to have variables for the left and right index of the actual return string. So result left, result right, we can just make it whatever. Make it like this. And we're going to have the left index of the sliding window. And finally, we're going to have a couple more things. So we're going to have the S count, which is just going to be the dictionary of letters in S, and the matches. So whenever T is in S, that means matches is going to equal T characters, right? like every time the counts are equal for a letter, we're gonna increment matches, and when matches equals t characters, that means every character in t has its correct count in s. So now we just do a standard sliding window. So for r in range length s counts s at index r plus equals 1. And now we have to check for a match. So if s counts sr equals t counts sr. Like I said, you could, what you could do is you can, in fact, we can do that. So we can just say, like, if it's a character we don't care about, we'll just skip it. Yeah, let's actually do that, right? So we'll just say, like, if it's a character we don't care about, it can never be, like, the best answer, so we'll just ignore it. So we could do that as well. So the way we would do that is basically we would say, like, if, let's do it over here. If SR not in, this is going to be t counts, right? If it's not in there, then just continue. So we could do that, right? Basically, if a character in S is not in T, we don't need to care about the count of that character. Like, it doesn't really matter. We just need all the counts of characters that are actually present in T. Okay. And because we're never going to make a valid string with one of these characters, right? Because our string will always start off invalid. We're never going to make a valid string with a character that's not in T. We're always going to make a valid string by getting one more match. So this should be fine. Okay, now we can do the rest of it. So S counts SR plus equals 1. Now, if the count of that character in S and R are equal, then we have a match, right? So if S counts SR. Oh yeah, I wanted to briefly explain, I wanted to briefly explain why when we have something, we always want to make it invalid really quick just before we do that. So sorry for stopping the coding, but I think that is kind of important. So let's say our string is this. Like, let's say this is our valid string. The reason that we always want to make it invalid is because adding characters to this string is never going to be a better answer, right? So adding characters to this string is never going to be a better answer because this is already as small as it can be. So for every valid string, you're never going to want to add characters to make it bigger. That's why you have to have the biggest invalid string with one character out, and then you can make it valid afterwards. So for a valid string, you're never going to want to make it bigger. That's why you have to make the string invalid first, then keep going. So I said I was going to explain it, so hopefully that makes sense. Let me know if you have questions about that. Yeah. So if count SR equals t counts, SR meaning the count of the character in S and T are equal, then we have a match. So we'll just do matches plus equals 1. And then basically we can just have a while loop while matches equals T characters, because if matches equals T characters, that means every character in T has the right count in S or more. So these are all going to be valid substrings, so we can just keep recording the length of it and keep shrinking and shrinking and shrinking until it breaks. So we're going to say while matches equals T characters, if result is greater than the current window, then we're going to update the result, and we're going to update our left and right indices. So result equals right minus left plus 1. Result left index is going to equal, we can put these all together, equals left right, right? So this is a valid window. We're just going to say, let's make the left and right indices of the result be the left and right of the window. That way we don't have to use substrings, and it's going to be super fast. So now what we have to do is we have to check if we had a match and got rid of it. So the way that would happen is, let's say the count in S is 1, like A had a count of 1, and in T, A had a count of 1. So if the count is equal, of the left character is equal, then you're going to lose a match because we're getting rid of characters from the left. So that means this A is on the left, they're equal, but now we're getting rid of a character from the left, they're not going to be equal, so we're losing a match there. So if S counts SL equals T counts SL, yeah, that's correct. Then we lose a match, and we have to no matter what, if we lose a match or not, we have to decrement the count in scounts. Now you can choose to say like when my count is 0, delete it, but it doesn't matter because it's 26 characters, so it's not going to make it like significantly faster. So I'm just going to leave counts that are 0. It's totally fine. So we delete it and then we just increment left, right? So we shrink our window, and we keep doing this until this is no longer true. And at every single valid window, like while this is true, we have a valid window, so we just keep updating our result. Then finally, at the end, we need to return the actual substring. So we can say return s result left, result right plus 1, right? Because it doesn't include this index, so we need one more. If result doesn't equal infinity, so if we actually did find a valid result, let's return that. Otherwise, if the result is infinity, let's just return the empty string. And let's take a look. Okay, I think we got it. Apparently not. Okay, so usually this is because I write left instead of right or something. So let's see. So this is fine. This is fine. This is fine. This is fine. That's fine. Yeah, that's fine. Oh, I think I see an issue. It might actually be this, because what I'm doing here is I am not adding a letter when it's not in T, but I'm still deleting no matter what. So let's just get rid of this. Like you can check for letters in here, but we can just get rid of it altogether and it should be fine. At least that might be one of the issues. Okay, there we go. So yeah, so you can handle it where if the letter isn't in T, you don't add it here, but then you have to also make sure to handle it in this case. So it's kind of easier to just add every letter, and it's not going to make it significantly slower, like I said, because there's only 26 letters, even if you don't count letters in T, so it doesn't really matter. Okay. So this is going to be time. So if S is O of N and T is O of M, then we have this like O of M plus N thing, right? Because we're basically traversing through each word once. So we're traversing through the first word once to get all of its counts. Like this counter is basically O of N or O of M. And this sliding window is going to be O of N. And as far as space, it is O of 1 because the counter of a letter, because there's only upper and lowercase English letters, that means there's only 52 letters maximum. So no matter how big the word is, like this word can be 10 to the 5th, but it doesn't matter because the dictionary is only going to be 52 letters for each word. So it's basically constant. So that's why using a counter of characters is really good if you have to pick options, because it's basically O of one space and time, and it's super fast. And yeah, like I said, this is going to be a problem that you definitely want to know. If we take a look at the companies, it is a pretty asked question. So, and I think it's like on the easier end of the hard questions. And there are a lot of questions that use this kind of thing where you need to see if all the characters of a word are another word. And the best way to do it is this like matches pattern. You just, every time the counts are equal of a character, you increment the matches. And then when the matches are exact to the number of letters in the other word, then you have like a complete, you have a valid window. Yeah, and hopefully this was helpful. And if it was, please like the video and subscribe to the channel. And I should be getting the videos for the rest of the bi-weekly contests in a few hours. So if you're looking for those, that'll be out soon. So thanks for watching.